another minute. I think we're good.
And for all of you here, thank you for joining us. We're excited to have you.
Yeah, I think we can get started, Colleen. What do you think?
Awesome. That would be fantastic. All right. So I think you all have my screen showing in front of you, correct? Beautiful. Well, welcome to our seminar. We are very excited to talk to you today. My name is Dr. Colleen Cannon-Rufo. I'm a solution architect with LEGO Education, and I'm here with my partner, Steph, and I'm going to let her introduce herself.
Hi, everyone. If you aren't aware, I am your LEGO Education Account Manager, Steph Chaplowski. I work specifically with private and parochial schools all across the U.S., and I work with schools to help develop their STEAM programs. And I am excited to meet with you today and share with you today. I work alongside with Dr. Colleen Cannon-Rufo. As she mentioned, she is LEGO Education Solution Architect. We work together to ensure that we can customize and solution our STEAM program into your school successfully. So today we're going to share about LEGO Learning System, and we're going to speak specifically about EANS funding as well. So if you have any questions along the way, please feel free to drop those questions in the chat.
Perfect. Thank you so much, Steph. So as Steph said, I am Colleen. I am your solution architect. I am one of 4 across the U.S. My territory is the Midwest and the Northeast, but I work with Steph across the entire United States on private and parochial, which is awesome. So having grown up through the parochial system myself, it's fun to be able to give back to my community. I spent 29 years in public schools as a teacher first, then as a technology integration specialist, and finished my career in the schools as a project manager. Most of my projects were related to educational technology and robotics and STEM, and that's partly what brought me to LEGO Education. So I left public education last year and switched to this role with LEGO, in part because what I was seeing in my school district, I think belongs in all schools. And I wanted to see how I could help make that happen. I feel very strongly and passionately about our solutions. I've been working with LEGO Education products for the last 20 years in the classroom, and then helping to integrate it into our curriculum in my school district before I came to LEGO. And then I also spent about 6 to 7 years as a LEGO Education certified trainer. So bringing it into schools across the country that way as well. Because of what I saw, because of what I see students doing when they're using our solutions, I just knew that I had to follow that. And that's why you see me here today. So just to give you a little bit idea of who LEGO Education is, yes, the LEGO group that you think of when you walk into Costco and Target and whatnot and see all those amazing models, that is us. That is the LEGO group. That is the umbrella company that we work for. Our division is LEGO Education. And LEGO Education is the division of LEGO that builds models around the instructional standards. So we are here to make sure that whatever we put into the classroom fits your curricular needs and your vision for your schools. So there is not a model or a lesson or a unit that gets developed unless there's an academic standard behind it, which is as it should be. So it is a phenomenal division within LEGO to work for. When you see this, most people, when they see this graphic, they see a pile of bricks, right? And absolutely, that is a pile of bricks. But we at LEGO Education, we see that these Lego bricks are a medium. We feel that they are a medium of expression, right? It is a means of communicating, a means of demonstrating your learning, a way of showing people what you're thinking and then ideating on that and then even iterating on top of it, right? So for us, we don't see Lego bricks as a toy. We see them as a teaching and learning tool, and such a powerful teaching and learning tool to grasp students and get them engaged in their learning. So I like to start with this slide. Students need to be prepared for jobs that have not yet been created, for technologies that have not yet been invented, and to solve problems that have not yet been anticipated. We have all seen this slide in one version or another over the last, what, decade and a half at least. It's not a new one, but it makes me think back to my first year as a teacher 30 years ago, right? And I went to a conference and I learned about this fascinating new resource out there, this new world essentially called the internet that was really starting to gain steam, and most people had never heard of it, right? And I think back to that year that I first started teaching 30 years ago. Here was a technology that nobody knew about. It wasn't in the classrooms, right? I had to take it back and teach other people how to use this within the classroom. And can you imagine a world where we didn't have that, right? Can you imagine a classroom where we didn't have it? How would we have survived the pandemic without it? That's the kind of thing that you think about, right? What are our students? What's going to be their internet? Is it AI? I mean, AI is definitely one of those new technologies that everyone's talking about, but how do we get them ready for a world that doesn't exist yet? Is that idea, right? And that's something that we're constantly talking about at Lego Education. For that reason, you can see our mission. Our mission is to inspire and develop the builders of tomorrow, enabling every student to succeed. And we take that word every very seriously. We truly want to see our solutions in the hands of every student. We want to see our toys in the hands of every student. We believe that they have that much power that we could really make a difference in a child's world. So we are doing everything we can to make that happen. So I want you to imagine for a second if every lesson taught in your school was actively engaging, right? Was so incredibly interesting to the child. They are so engaged in what they're doing that they don't even notice what's going on around them. That it was joyful. What does joy sound like? What is the sound of joy in the classroom? Go ahead and pop that in the chat if you don't mind. When your classroom is joyful, what do you hear? Laughter. Absolutely, Tate and Betty Ann. Thank you. It's exactly what you hear. You hear laughter. Is a joyful classroom silent? Very rarely is it joyful. Not saying it can't happen, but very rarely is it silent. You hear chatting, you hear communication, you hear kids talking, right? Absolutely joyful. Meaningful. When whatever those students are doing means something to them. They're looking at that new experience, they're connecting it to those experiences that they've already had. They're connecting that known to new. It's meaningful to them. Socially interactive, right? Socially interactive is that idea that they're not just working on their own, they're working with someone, they're collaborating, they're communicating as they're doing that. And that it's iterative. They're doing something, they're building something, they're creating something, and then they're making it better, or they're saying that didn't work, failing on it, and going ahead and building on top of that and making it even better, right? That idea of iteration, that idea that they're going to continue learning and continue building until they get to that next level. That would be a pretty amazing classroom, right? If you had just even a couple of these, not all of them. These are the 5 characteristics of play. And at Lego Education, we believe that play is an important element of learning, right? And when you find, you don't have to have all of, they don't all have to be present, but if you have some of them, right, 1 or 2 of them, that those characteristics are really going to lead to a powerful classroom. So where are schools using Lego Education? When you look at where we are using our solutions in the classroom, it's truly across the curriculum, right? We're using them in the science classroom. We are using Lego Education solutions in the computer science classroom. People are using them in robotics or in their STEAM classrooms, or perhaps in a STEM curriculum within the core classroom. There are people who are using this to support their ELA and math curriculum. I've had teachers ask me about how do we use these in CTE and in career to have those career conversations, or social emotional learning to adjust how we can really negotiate and have those relationships with one another. So when people ask me, where do you see Lego Education solutions in the classroom? I tell you, it's everywhere. It really depends on what your curricular need is, what your curricular vision is. because we've got lessons that will fit those. I like to give people a visual of what this can look like. Oh, and Steph, you told me to turn on my sound and I forgot. So I have to stop sharing and start sharing again in order to put the sound on. I apologize for that, everyone. Make sure I get it right this time. Share with content and sound. There we go. Now can you see my screen again, Steph? She does her best to prepare me, and yet I still manage to forget.
Our students deserve authentic hands-on learning experiences.
It definitely does not feel like school, but we are definitely learning.
Now is the time to be bringing joy back to learning.
Students have to connect with what they're learning, and through joy, they'll have meaningful experiences that will stay with them.
I love playing with Legos, I love coding, so when you get to put those together, it's literally a dream come true. And then adding the factors that you get to work with other people, it was awesome.
If they feel joy, they are intrinsically motivated. They're feeling more confident in themselves.
Lego has a mission to transform the way kids learn.
This is something that I've always wanted to put in the hands of our students.
When it comes to computer science, the coolest thing is to see the multiple ways that someone can solve a problem.
For us, Lego Education was a natural fit. It has that familiar name of Lego, and it allows the students to access it at any level.
I can't put into words how appreciative I am that I got to do this with them.
STEAM belongs everywhere, in the school day, out of the school day, at home.
I think every school should do it. It's a great way to learn. It's a great way to have fun. It's a win-win.
The little guy is awesome. It's a win-win, right? But I loved when he said it's a dream come true. That sound that you heard as the students were cheering, that was actually one of the things that truly drew me to studying Lego education more and trying to figure out what was making this experience different for kids. And I couldn't get over the fact that, you know, as students were solving a robotics maze with the, getting the robot to move through the maze, the kids who solved the problem would cheer. And that was awesome, right? But so would all the other kids in the classroom. And I think that was the thing that always got me was, how often do kids just spontaneously cheer, not just for themselves, but for the other kids solving the problem, if it's on a worksheet or something like that in a more traditional manner, right? But you give them an experience like this, and the whole room just erupts when they have those moments of solving that problem. It really is it's an incredibly powerful experience. We like to talk about our solutions as an integrated continuum of learning. It's a learning system. Just like Lego built a system of play with their bricks that people, can build something and take them apart and build them into something, completely new. We did the same thing with our learning solutions, right? We're trying to build a system of play. Within that system of play, there are 5 different components. The curriculum obviously is the first part. Nothing with Lego education gets built without a curriculum behind it, right? And lessons that support it. Of course, if it's a Lego education solution, it's going to have its bricks. We have programming in our digital solutions as well as intelligent hardware. And then we put professional development behind all of that. So I'm going to move forward to this next slide and kind of show you a little bit about that learning system. So we start in that kindergarten level. We have solutions such as our Story Tales, our Coding Express, and our STEAM Park. We have a couple other solutions as well that I'm going to talk about in a second, but those are our early learning pre-kindergarten, kindergarten solutions. In the middle, you see our primary solutions. Those are the ones that we have in our elementary schools. We have the Spike Essential at the top up here, and then we have the Brick U Motion Essential, which is our the Brick U Motion Essential. The Brick U Motion Essential and the Brick U Motion Prime, both of these on the bottom side of this line, represent our non-digital solutions, right? Whereas the top 2 up here, Spike Essential and Spike Prime, are our digital solutions. So they allow you to add that computing concept to it. And then, of course, these last 2 over here on the right would be your secondary solutions. So those are the solutions that we have at the middle school and the high school level. I'm going to talk real quickly first about those early learning solutions. This represents our portfolio of early learning solutions. We have 6 key solutions within that early learning portfolio, and then we have 6 booster sets. The key solutions have lessons and curriculum attached to them. So they'll have, lessons that basically follow the standards that they're trying to address, that they'll do first. And then on top of that, we have our booster sets. And our booster sets are the ones that kind of enhance those original solutions. Steam Park, Coding Express, and Story Tales are the 3 early learning portfolio solutions that we suggest for the kindergarten level. And then the other ones, we would use more in the pre-kindergarten solutions. One of my favorites is the letters, because that really lets us get into literacy and start building our solutions and really incorporating the literacy into those solutions. I'm going to move forward real quickly here. This is a picture of our Spike Essential Kit, and I was trying to give people a sense of what the kit contains. We had talked about how the solutions have our bricks, of course, and you can see the bricks are sorted by color, and they also have that intelligent hardware. So you see the little motors and the light matrix and the color sensor, as well as the hub that you'll be doing the programming on. All of that comes within this one kit, and the one kit can be stacked really easily in the classroom. But I wanted people to be able to see that all of our solutions that we have, all of the models that we have, come from that one kit, right? Because people will often say, well, how many different kits do I have to buy? And my answer is just the one that is going to be able to build all of these different models. And that's not even all of them, right? That's just some of them. And then on top of that, if these are the ones that we're suggesting, think how many the kids can create beyond that, on top of that, right? And it just gets pretty amazing to think about all of those different models that can be built just with that one solution in your classroom. So that Spike Essential Kit is one that we use at the grades 1 through 5 level. This is just looking at those components within our system, right? Just from a different perspective. So again, you have the curriculum. The curriculum starts pre-kindergarten, elementary, all the way through. We have the units, the lesson plans that follow a theme and that really progress as the students progress. We have our bricks within them, starting at the early learning. We start with the Duplo, we move into those system bricks, and then from the system bricks, we move into the Technic bricks, which really allow for more sophisticated programming and modeling. In the middle there, you see that we have, for our digital solutions, we have a progression in terms of the coding that they have. So they start with those first lessons with the Coding Express, where they're running the train on the train tracks, and these little action bricks will react to the color sensor on the bottom of the train. So they're starting with those sensors and the programming using physical computing. From there, they move into our elementary solution, which is based on the icon block-based coding, which is more appropriate for our emerging readers, right? And then from there, they'll move into that word block-based coding. At the middle school and high school level, they pick up with that word block-based coding based on Scratch, but they can go all the way to the text-based coding with Python, which is pretty amazing to think that all of that is built within the same app. And then, of course, our hardware grows with them as well. So starting with the small little train that they use when they're programming the track in Coding Express, moving to the smaller motors and the smaller hub with 2 input-output ports in the elementary solution, to the secondary solution, which will have the larger hub and then 3 different sensors, as well as the larger motors. And of course, all of that has professional development that underlies it. So moving on to this next screen, I wanted to kind of talk about what that progression looks like. So I thought I'd start first with the BrickUmotion, which is our non-digital solution. So this is an example of a lesson that the students would do where they're building ramps. In building these ramps, they're learning about forces in motion, and they're learning about how gravity affects this, right? And what causes this car to roll down the ramp. And then they're starting to begin to explore that concept of science without necessarily having to know exactly what it is, right? As you have those conversations, you're going to ask them, well, how does that car start, right? How do we get it to start rolling down the slide? Well, that happens with a push. So now they're talking about pushes and pulls and having those conversations. You ask them, just like in science, we want to predict what's going to come next, right? So how far is that car going to roll? And they're using those number blocks to be able to make some of those predictions. Well, then you take a look at the next level, this is a similar lesson, right, based on those same concepts in science, but we're taking it that one step further. So this is the bobsled model that they're going to build. And the students are going to explore how gravity affects the motion of the objects here. They're going to explore the difference between bricks that are weighted and bricks that aren't, and how when you add mass, now we have momentum, and momentum is going to play into that, right? So they're beginning to explore these concepts of forces in motion, and that continuum progresses as they get to the next level. And now they're going to start looking at that same concept, and they're going to be exploring how does this skier, slide down this ramp, and how is mass going to affect that as well, right? So if we add more weight to the skier, is that skier going to go further, or is it not going to go as far? So they're really starting to explore Newton's laws of motion, right? That object in motion stays in motion. But now we're also bringing the angles into it, because they're going to start changing the incline of that ramp to see what's going to happen. Is that going to go further? Is it going to go not as far? It's that idea of inquiry-based learning, right? That you explore these concepts through hands-on learning to be able to internalize them so much more once you've gone through that exploration. So that is an example of a progression of a concept or skill within our non-digital solution. We have those same progressions within our digital solutions as well. So I was talking about that Coding Express for our early learners, right? You can see the Coding Express train on the track up there, and that train is going to be use the little color sensor on the bottom to be able to read the action bricks to stop, or to play a sound, or to do something different. And the students are going to start seeing how they're actually starting to internalize those computer science skills, right? The first lesson for Coding Express is actually a sequence. It's called First Trip. So they're stopping, at the first stop, and then they go to the second stop, and then they finish at the final stop. Well, that's the idea of sequencing in computer science, right? Then they build this O-shaped track that you see up here on the slide, and they're starting to do that same sequence, and then they repeat that sequence. So now they're seeing that looping concept that is such an important concept in computer science. And then they finish by building these tracks that go in different directions, right? So if it goes in this direction, it does one thing, else it goes in a different direction and does another thing. That's that idea of conditionals in computer science, right? We're not teaching them about conditionals, we're not teaching them about loops, but we're letting them experience them so that they're having that educational experience using those concepts and being able to build and understand on top of those. And then we continue that progression. So now they've used the color sensor on the bottom of the train in pre-K kindergarten. They move into first and second grade, and they build the fast lane. And now they're building that little sensor, color sensor, to read the color ticket. And they'll either get into the fast lane based on the color of their ticket with a green light on the matrix, or they'll be told, no, it's not the right color. And they're the ones doing that programming. And we continue that progression on to the next level, where they're building the trash monster machine. And now they have to have they're trying to make it a little more interesting for people to get the garbage into the garbage can instead of next to the garbage can. So if the garbage makes it in, that sensor inside is going to say, oh, we see it, and then it's going to react in that way, right? So it really kind of gives them that idea of how they can use that sensor to begin to change behaviors, right? They can also start talking about, well, how could I iterate on this build? How could I make it better? Maybe it shouldn't even open up until after I show it the garbage, so that it could be a recycling bin versus trash, right? So now they can start talking about sorting, but it gets them to think about how those sensors are used in their world. And then it finalizes with our automated, right? And this is an example of something that they're going to build that says, okay, if this is one color, I'm going to pick it up and put it in one place. And if it's a different color, I'm going to pick it up and put it in another place. I love that. It's from our Kickstarter business unit, which is all about automation. And I think it's phenomenal for kids to see that robotics aren't just vehicles that move, right? Robotics is everywhere in our world. It's part of what we're doing to automate our processes in our companies and in our businesses. So it's that idea that we take that concept of students are using sensors, right, to be able to have the robot adapt to the information that it sees and do a different action. So that concept starts in kindergarten, and we bring it all the way through until they're in the middle school, high school level. And that's the thing I love about our solutions, that we have that progression of learning, that we've looked at what it is we want students to learn, and then we've built those lessons accordingly throughout the years. And of course, we talked really quickly about the programming, right? But that programming starts with those action bricks. It starts in those Coding Express on the train track. So they're physically programming as they're moving that train on the track. We move from there to the icon blocks so that they're learning how to program without really having to know how to read at this point, right? And then moving from there to the word blocks. Both of those are based on Scratch Junior and Scratch, right? So it's a familiar programming language and one that they're going to be able to transfer if they're using other products as well. But I love that we can bring them all the way to Python. We can bring them all the way to that text-based learning, all within the same environment. So I think that's a huge thing for students to be able to see as well. And staff, have you been able to answer all of our questions? I haven't paused in talking. Does anyone have any questions at this point that they want me to address?
We had Jennifer ask a great question, asking how many students per kit do we recommend? And for the elementary and secondary, that's 2.
Definitely 2 kids for you don't want to see one person on a kit. That's just not the way we operate, right? Because part of what we're trying to do is build in those 21st century skills of communication and collaboration. We want them to be able to work together and figure things out. When you get to 3, it gets tricky because at that point you have that one set of hands that just doesn't seem to be doing as much. So it really, the sweet spot is 2 to 1 with all of our solutions at the elementary and secondary level. Different numbers when you're talking about the early learning in kindergarten. So we wanted to share these this customer success story. Essentially, this is one of the schools, and Steph, you can jump in here as well, that has shared pictures of what they've built in their STEM space, right? They just had their ribbon cutting last week. So I think they've done a beautiful job of organizing all of their materials. But I love that she shared with us the pictures of what the students were building. You won't find these builds in our lessons, right? These are builds that they did based on those lessons. So they're taking that next step, right? They've done some of the amazing amusement park, and now they're going to build their own amazing amusement park. Or they've done the animal alarm, and they've taken that next step and said, okay, well, I'm going to build this component on it. And I love seeing what kids actually do when they take our ideas and our solutions and they build on them from there. So it's phenomenal.
Can I just add to that, Colleen?
Yes,
what was really exciting about this wonderful school is that it's an all-girls school. So I think that was just so fun to work with them, and so that they had this STEAM lab built specifically for the girls.
That's phenomenal. Thank you for sharing that, Steph. I appreciate it. We just want to point out that all of our lessons are standards aligned. So we have standards alignments for all 50 states. So if that's something that you need, you can work with Steph and she can get you those alignments so that you can see which lessons are aligned to which standards. We also have learning extensions. So if you take a look, if you look at our site, you see all of these amazing lessons that are out there. We call those our inspiration lessons. But beyond those inspiration lessons, we also have additional curriculum. We have a Build the Change curriculum, which really uses creativity to solve real world challenges. One of the curriculum is called Biodiversity and Climate Change. Talk about a timely concept for us to be talking about, right? Build to Launch is phenomenal. This is one that we created with NASA. It's all about STEM careers at NASA. And they took our lessons that we do, and they basically set up these challenges that reflect things that happen as you're trying to get to space or once you're on the moon, right, in space. And I think that connection that they're making to NASA is huge. These 2 little minifigs in the middle here, Kyle and Kate, they actually went on Artemis to the moon. So there's only 2 sets of those out there, and one of the sets actually got to travel to space. Those little minifigs interview the different people that are at NASA and their different careers. And it's really fun to see the kids respond to how Kyle and Kate are introducing us to the world of NASA. Rebuild the World is another curriculum that we have that's fantastic. It's about STEAM careers. And it it again launches from some of the lessons that we have already, but then gets kids to think to more open-ended responses, right? For example, there's one where there's a bee rescue couple. This couple basically is their job is to do bee rescues, right? So the video does a beautiful job of explaining that career, and then it challenges the students to think about, okay, if you had to move the queen bee in order to move an entire hive, what would you build in order to make that happen? So it really kind of sets the challenges, and a lot of what we do, right, is all about problem-based learning. Here's your challenge. What would you build in order to solve that problem? And I did want to point out that we also have lesson progressions. So those lesson progressions will take you not step by step, I shouldn't say that. These lesson progressions are by grade level, and they give you suggestions on how you can approach our lessons, but then also how you can extend on our lessons. So if you want to do more math, here's some things you can do beyond this lesson. If you want to do more around ELA or more around computer science, here's some things that you can do to extend upon that lesson. So we have lesson progressions from first grade all the way through 8th grade in our Spike programming. So it's pretty amazing the amount of materials that we have to support teachers. You should not have to create anything on your own. Truly, it is that that's scaffolded for our teachers. The other thing I like to point out is that we have the learning extensions with the Tufts University placemats. If you're not familiar with these, they're phenomenal. At Tufts, they've been creating all these different challenges. They're actually 2 Google slides, basically, right? The first Google slide sets the challenge, asks them to think about a couple careers related to that, and then gives them some example ideas of what they could build without telling them what to build, and then gives them some ideas on how to build it. I think that's truly key because they're starting to think about the engineering behind what they're doing, right? And then some examples on how you might control it or how you might code it. So without giving them answers, they're kind of giving them some ideas on how they might go about solving some of these engineering challenges. So they've done a beautiful job of building these placemats around our solutions. Carnegie Mellon also has some phenomenal curriculum, free, of course, just like Tufts, that is based around our solutions. And they have an entire curriculum that you can follow called Coding and Computational Thinking with Spike Prime. So just letting you realize that even if you shouldn't need more than what we have, but if you do, there's more out there being created by other people in this space. So. And then I like to show this slide just to kind of give people a sense of what it could look like, right? These are not lessons that we teach. These are all creations that students have built using our products, using Spike Prime. And I think it's amazing to see the types of builds that can be built with Spike. I think I've had people say to me, it doesn't seem to be too much. It's just that one small box. But look what that one small box can create. It's pretty impressive when you think about it, right? So I like to give that as a sense of where we could go if we just give them the chance, right? Sorry about that. We just give them the chance to go beyond. And everything's ringing. That's amazing how that works. I also wanted to talk to you about professional development because we offer professional development as well. And I think it's amazing professional development. I did this myself for 6 to 7 years before I came into this role. We have probably about 50 trainers across the US. Some of them are teachers who have retired and they're continuing to do this in their retirement. Some of them are people who have actually left teaching and they're doing just this as consultants for Lego education. And then some are still in the classroom and they're doing this on their summers or on their weekends or when they can for Lego education. But they all have a background related to using Lego education products in their classroom. They bring such a wealth of knowledge to the conversations as they're training. It's not just about our product. It's about classroom management. It's about 21st century skills. It's about pedagogy and good pedagogy. So you really get a lot of bang for your buck when you do the professional development through us. We have a school district that's a school that's using this in Arizona, that set up 2 years worth of professional development, which was beautiful, so that they could start them, get them exposed to and, trained on our product, but then they're continuing that conversation. So we came back in and did next steps with computer science. We actually put 3 of the teachers to the side and had them work on Python because only 3 of them were ready for that at that. So we're even differentiating within our professional development. And then we have coaching that they're going to be doing throughout the school year as well, in order to be able to continue that conversation, to have them set goals and then to, kind of be able to talk through those learning experiences. This is a school that doesn't have a lot of experienced teachers. So that professional development was a huge part of what they wanted when they purchased our solution, right? Because they needed a way to train their teachers. And like I said, our trainers, I think, are some of the best out there. So that professional development was covered through that EANS funding as well. So talking about funding sources, right? EANS is one of the ones that we're seeing a lot of people use right now. That's that Emergency Assistance to Non-Public Schools program that was a result of the Coronavirus Response and Relief Act, right? And then also the American Rescue Plan Act of 2021. In addition to EANS funding, people are using private funding sources such as family engagement nights or PTAs, home and schools, tuition. It's always amazing to us to see how many different ways people fund these initiatives that they have within their schools. So lots of different ways to go about that. The reason we wanted to make sure that we talked about EANS is because round 1 is closing on September 30th. So we want to make sure that if people haven't spent their funds yet, that they know that, hey, that deadline is looming, right? So that is through September 30th of this year. The second round of funding will go through September 30th of next year. So keep that in mind. We also work with Class Wallet in the states that you see listed on this slide so that you can see if that's easier for you in order to get those funding sources. Steph has done a lot of work with that. So Steph, did you want to add anything related to the EANS funding?
Just that I know that not really aware if they even have EANS funding. A lot of the times maybe the principals will know, but this is a nice snapshot of why or how your school would be eligible for EANS funding. A lot of the times when you do have EANS funding, schools aren't even aware they can use EANS funding with LEGO education materials and professional development. So that's why we found it very important and imperative that we brought across that message that absolutely you can use EANS funding with LEGO education.
Thank you, Steph. And then I also wanted to share this slide because I think this is an important thing to point out, right? People often come to us with one purpose, right? I have a need for a STEM program or a STEM initiative, or I want to do some summer programming. But once they purchase our solution, it's yours for life. So there's no need to repurchase after that point. There's no subscriptions, yearly subscriptions for our software. All of our software is free. All of our lessons are free. All of the curriculum that I talked about is free. So as long as you have our resources, you're going to be able to use them in whatever way you need to. And I think a lot of schools have done a beautiful job of basically getting the most bang for their buck as a result, right? So either way, I just wanted to point that out as well. So that was kind of what we wanted to talk to you about. If you have any questions, title funding, yes, we definitely can use title funding as well. So absolutely. And I see some, does anyone have any questions they want me to address? I'm going to really quickly, Steph, if it's okay, hop on to, do I have a few seconds left or have I gone over time as usual?
You're good.
You keep me on track. Thank you. I appreciate that. I just wanted to show you really quickly our website, education.lego.com. And when I go to the website, I can show you that I go to teach, unit and lesson plans, and everything that all of our resources, whether they're current or retired, can be found on here. So there are those Spike Essentials kits that we were talking about earlier. The Spike Essential, you can see all of the different units for them. I can load more if I need to, or even more. And then from here, I can go into the unit itself and you'll see that this shows the different lessons within the unit. I want to point out that the lessons can be accomplished in 30 to 45 minutes, right? This was very important in our latest iteration of Spike, essentially. Teachers said to us, we don't have 3 days to do a build. We need to be able to build and program in the same time frame. So that's what we did. We built models that could be accomplished, that could be built within a class period, and also programmed. And I think that's an important thing to note, right? I also want to point out that our lessons are hugely scaffolded for our teachers. They take them through a lesson using the 5 E's framework, that inquiry-based framework for education that starts with the engage, moves to the explore, from there to the explain, elaborate, and evaluate. And along the way, we're giving the teachers discussion prompts so that they don't have to come up with those discussion prompts on their own. We're giving them tips about how to code. So we recognize that teachers don't always have a computer science background, or they might not always have a science background. We're going to provide as much background as we can to scaffold them through that process. We do the same thing for the builds so that we can help the students iterate on their builds so they can make them better, that they can improve them and use those engineering skills. And at the top, they'll also see a little video, and that video is 3 to 5 minutes long, and it's talking to the teacher about what the model is that they're going to build and what the programming looks like behind it, and giving them some classroom tips on how to do that along the way. Doesn't matter what lesson you're in, doesn't matter what unit you're in, it's going to follow that same process, or that lesson plan is going to look exactly the same in every single unit, every single grade level. Again, we're trying to make it as simple as possible and scaffold the teacher as much as we can in doing that. And then I wanted to show you really fast our app. It is now web-based, which is phenomenal, right? So you don't have to worry about whether or not it's going to work on a certain device. We still have apps that you can download. If the students have their own devices, that's great. But if they're on shared devices, they can go to spike.legoeducation.com. Depending on what solution they're in, they can click into that solution, and then they can go into their unit plans and straight into that amazing amusement park, and they'll be able to follow the lesson for that student. I love that at Spike Essential, they're based on a story. So you see the ELA context within there, right? So the students are given a problem. They're told that, basically we need you to help us solve that problem. And then the build instructions are right within that app. So they don't even have to go anywhere else to get those build instructions. And then from there, it says, all right, help me build this model, right? And then this is our challenge. We're going to build this model that's going to turn the light on when he shows them the yellow ticket, and then straight from there into the interface itself. It's seamless. It's meant so that it's student-centered. The students working in partners can do this on their own without the teacher having to lead them. The teacher gets to be the facilitator, gets to help them take it to that next step. And you'll see even to the point where it's helping them build the actual code that they're going to need to build to initially program the model. We want them to be successful from the minute they start, right? So they've got this preliminary code that they're going to use. They press play, it works. They start to iterate on that code. They start to play around with it to see what it does. The teacher might say, hey, why don't you see if you can do the same thing? Get it to react to a green ticket instead of just a yellow ticket. Now they're parallel programming. And then the next step says, now let's make it a little bit more complicated. Notice the menu palette opens up on the bottom, gives them a little more to program with. So it starts to get a little more complex without overwhelming them in the first place, right? And then as they go even further, it opens up even more for them to program with. And now they're asking them to iterate on the build as well. So just a real quick way of looking at this from the student perspective, I can switch between Essential and Prime, and now I'm into that next level for the middle school and the high school students. And I can go into that Kickstart a Business and take a look at Place Your Order and follow the same thing. It looks different for the next level because we're going to be using that word block based coding, right? We actually have word block based coding for the through fifth graders as well, but the lesson plans are on the right. The build instructions are right there. They give them the code to get them started, and then they ask them to make the changes and to get, it becomes more complex as they go along. And it starts to open up, even though you see the code that you need to be successful with the task, you have the ability to click on Lesson Spike Prime, and it pulls up all of this different code that they can be using. So it really lets them, I think, get into a whole nother level of programming than we were ever able to get into before. All right, now I will stop talking and I will ask if anyone has any questions.
I think, Colleen, everyone would like to know where we're going to go from here, how they're going to be able to be in contact with me, or I can contact them. I dropped my email in the chat, but yes, Colleen, that's the slide I was hoping that we could share. On this slide is a QR code that'll bring you directly to my calendar, so you can feel free to schedule some time with me. What I would love to do is meet with you to learn more about your school and your goals for your school. And then I can share more about Lego Education Solutions so we can find the best fit specifically for your school. We will customize something for your school. So I'm happy to meet with you. Please feel free to scan the code, also email me, and we can connect after this meeting. I will be sending a follow-up email as well. That'll be recorded to this webinar.
Perfect. And then I also am going to put that slide up so they can see your email as well. See both of ours on there. And like Steph said, reach out to Steph, see what, set up a meeting so that she can help figure out what it is that you need. And my role as the solution architect is to work with her for those schools that I usually work with larger implementations, but it's that idea of where does it fit with your curriculum? And I help figure out where that need is within the curriculum as well. So we're here to support you. We're here to help you on this journey, and we'd love to be a part of it.
Thank you all so much for joining us today, and I look forward to meeting with all of you. Have a great afternoon. Thank you.
Thank you so much.